Good afternoon. I think the basics is known to all of you. Initially, do open the MATLAB, then open a new M file. Now, in M file, if here if we see read the system data, now we will solve the problem for 34 bus system, and in 34 bus system a few data is supposed to be known to us, that's supposed to be bus data and line data. Therefore, if for consideration purpose I will add bus data and line data, I will share this data file to you in that WhatsApp group, so all of you can load it out. Bus data and load data, it supposed to be is equal. We have to call this file in the name, whatever the file name is over there. Here I have saved this file in the name of data34. If I open the data34, it's something like that. Bus data for all of the node is given over there, and as well as line data. This load data bus number 1 is considered as a substation bus, that's why its load is considered as 0 and 0. But for other node, a certain data is available, and we have noted down over there. These are all load data. Thereafter, value of x, whatever the value of r and x. The same thing is written for 34 bus system, and we supposed to load this data over there. Therefore, this file is saved in the named as data34. So we'll save this one as data34. Now, if I want to see what is total bus data is over there, total active power demand is over there, then we can calculate it out. Whatever the sum of this all active power demand, if we add it out, we can calculate it out, total active power demand over there. So just do write like this way. Okay, just a second. Let me share it. Okay, I have shared this data file in this group. So yes, it is working fine, I think so. So basically what I have did, I have initially in first line I have read all of the data, and thereafter I add what was our total active power demand over there. So simply I use this sum command, and if you remembered in morning we have a discussion at that time, our total power demand on a general scenario it was 4636.5 kilowatt, and when I execute this one, it is hopefully coming 4636.5. Okay, it is e to the power 3. It is showing like this. Okay, let's write format short g. So let's run. Yeah, it's okay. It's the matching with this. Now at the same time, if we see what is reactive power demand, we can calculate it out for reactive power demand also. Just give and try for reactive power demand. And in bus data, if you see in bus data line number 3 is indicating for reactive power demand, and just check it out what's supposed to be the value. Yes, 28.75 kbar, and the same is matching with this. Okay, initial demand is same for active and reactive power. Now we'll try to formulate this backward forward sweep methods, and we'll try to calculate whether this losses is achieved or not. So here write few more things. CLC clear all. Here initially we have to calculate our conversion. We have to carry it out R and X in per unit value, because those value is given in ohm unit. So we have to carry it out this per unit conversion, and for carry out this per unit conversion, we have to write what is base MVA and base kV voltage is over there. So for this system, base MVA base is 100 MVA, and for kV base it is 11 kV. Now what will be the value for ZB? It's supposed to be kV square by MVA. So based on that, we'll get the value for Z base. Now if I gone for the conversion of an per unit system, so here we have to calculate for all of the branch per unit. The value for R value and X value will be different for all of the branch. So initially this we have to start an for loop for I equal to 1 is to branch. 1 is to branch. Now what is this branch? How we have to identify this branch? What's supposed to be the size or length of this branch? How we can define? What is the length of your line data? That will be your branch. So before write it BR, as it is MATLAB, it is not known to us what is BR. So we have to define BR is equal to length of line data, LD. Now in line 4 we have colon file, this data file 34, and from there what we obtained? Batch data and line data. And when line data is known, then if we write BR, then it will be known to the whatever the how many branches is over there for this specific system. And number of a node if we define, then which data, how can we define this number of node? If we write length of batch data, then we'll get the number of node. Now right now let's move for this conversion. For this R and X conversion, for first bus, if I write I comma 1, it is supposed to be whatever the batch data over there, I comma, sorry, it is not batch data, it will depend on line data. R is actually depends on line data, na? Not batch data. Do correct me if I went something wrong. Line data, it is which data? I of 4th row. If we see this one, so R is situated on 4th row. So it's supposed to be line data I comma 4 divided by whatever the value of Z base. Whatever the value of Z base. Similarly, for X also we can calculate it out. Its calculation can be carried out like this, comma 1 is equal to line data, which one? It's supposed to be I comma 5, because here if we see on 5th row its X value, actual value is given. So for per unit conversion, what we have to do? Actual by base. So actual value is given this one, and base value just line number 10 we have calculated out the value of base value. So that's supposed to be Z base. It's okay. For conversion of R and X. Similarly, we have to do the conversion for active and reactive power demand also. For active and reactive power demand also conversion. Now for the active power conversion, if we go, what it will be for again I equal to 1 is to number of node. How many node is there? Based on that we have to do the conversion. So it's a number of node, NO. Here NO we have defined it out earlier. So from there if we calculate the value of P of I comma 1 is supposed to be is equal to B of comma 2 divided by whatever the base is over there. It is 1000 into MVA base. Similarly, we can carry it out for reactive power also. Is it okay up to this much? Any query? Up to this much all data are given, line number 8. Then we have done a necessary conversion to calculate it out the per unit conversion till now. Now we will go for the formulate of BIBC matrix. We will go for the calculation of BIBC matrix. Now, but before moving to the calculation, let us check whether we are getting all P and all Q value in per unit or not. Just write capital P, whatever it is coming, and we will check these two also. Okay. Just see whether you people are getting same or not. Whether it's a number of branches is supposed to be 33 and a number of node for this is supposed to be 34. Whether you people are getting this one. Not. You just do call this line number 4, and after that just write branch length of LD. Initially you save the line data, whatever I have shared in this WhatsApp group, you save in a folder and create another file in same folder, then it will be linked up. And how to call that file name was saved as data underscore 34. So this line actually used to calling the data. This line is mainly used for calling the data file. You will get this one definitely. Your branch it is supposed to be 33 branch because the node is 34, so in between branch will be 33 and node is supposed to be 34. And after obtaining this one, we gone for that per unit conversion. Whatever the earlier value of P and Q was there, it has been right now converted into in per unit with respect to its when we consider MVA basis as 100 MVA and KB basis as 11 KB. So it is converted to this scenario. Rashmi, it's coming to you? Yes. The same data? It's okay, fine. Dipanshuji? Okay, now move ahead. Now our next part is to form the BIBC matrix. Now I will go to our previous slide and it will help us to formulate this BIBC matrix. This matrix is known as BIBC matrix. If you recall in our first hour lecture, this matrix was BIBC matrix, and here when we calculate it out, what was there? If we calculate the branch current 1, then it's supposed to be connected with all of the node, and if we go for the any dead end side B4 or B5, it is connected with only which bus is connected over there. So we have to make some calculation. If this one 5 is connected with 4 or 4 is connected with 3, based on that we have to derive a logic. I am just writing that logic over there, and just do check whether it's working or not. So initially we will consider BIBC along with BCBB matrix as 0 for initial scenario. This branch node, everything is working okay, then put the semicolon, no need to check it again and again. So here I write BIBC is equal to initially zeros of It's here I have defined initially it's a 0 cross 0 matrix, so it's coming 33 cross 33. I hope a matrix is coming 0 cross 0 matrix initial formulation. So simply what we have done, initially we create this matrix based on how many number of branch is over there. Here we have 33 bus, so our matrix size will be 33 cross 33. No value is putting over there, so simply I have put its bi cross this is size is something like that. ABC is I comma 3. Yeah. Here, what I have done initially, I have designed its zero size matrix, then checked when it's supposed to be 1. If this node is connected with other node or not. When it is connected, then we put it as 1. There, otherwise it is supposed to be 0. Now, we remember that this is as a first node, and node number 1, it is supposed to be connected with all of the node. If you see this 34 bus diagram, roughly this one is faded current for all of these remaining 33 node bus. So the one value will supposed to be there. Similarly, for this one, it is supposed to be only here it is supposed to be 0, for other node it is supposed to be 1. But if we go on for the 13 number of a node, it only possibly supply only 13, 14, 15, 16 branches connected. So their value will be 1 and other node value supposed to be 0. So let's check for 13 number of 1 whether it is working properly or not. If I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Tentatively this one is 13, it's supposed to be connected with only these 3 node. Only these 3 node it's supposed to be connected. Other matrix actually this size is quite bigger. Other size if you see on 13 it's supposed to be 0. So in a rough way, if I say here is also 0, only it is connected when your node, this 3 node is connected over there. So somehow we able to formulate the BIBC matrix. The logic is there. If we consider when it is equal to as 1, then it's supposed to be 1 if it is connected. If it is not, then keep it whatever it remain. Similarly, we have to go on for the calculation of BCBB matrix. BCBB matrix for BCBB matrix also, what we have to formulate? We have to formulate a matrix where this impedance calculation can be done. If it is Z connected with Z12 or whatever supposed to be the voltage different in between bus 3 and bus 1, based on that BCBB matrix is defined. Here also if a certain value is there, then we will calculate it out whatever the value of R plus Jx, otherwise we will keep it as a 0. If you want, you can write it down, this 4 line. This is simply for BIBC matrix formulation. I have used a simple if else statement over there. Now inside this loop, we will try to write it down that BCBB matrix. In BCBB matrix also, like earlier, see for BCBB matrix, what we have to represent in BIBC matrix, we represent 1 or 0 kind of thing. But when we go on for BCBB matrix, we have to calculate the value of Z, impedance value we have to calculate. Yes, impedance value we are supposed to calculate, na? Because that is related with whatever the impedance is over there. So if we write, it's will be something like that, complex of R into x. If these two are connected, then we can write it like this way. Else let's see how whether BCBB matrix is coming or not. Yeah, it's working fine. We are getting the value for the BCBB matrix also. Now I will explain why I use if and else statement over there. If statement that is for diagonal component calculation, and else that is mainly for off diagonal component calculation. This matrix calculation part we have carried it out over there. When we have this size BIBC, comma, from this notation we can identify that if it is for first scenario I equal to 1, so line data 1, 3, whatever the value of a line data minus 1, and this same notation, either it will be 1, 1 or 2, 2, something like that, it will be the 1 for BIBC matrix, and for this matrix, for BCBB matrix, its value will be the whatever the value of Z. And for off diagonal, we do a slight calculation. Here you may see it's 3 minus 1 is supposed to be is equal to 2 minus 1, line data of 2 minus 1, and logic we can develop it like this way. And similarly for BCBB matrix also we can carry it out. Now the thing for BCBB matrix Z12, for first node it's only connected with one node and others all are 0. For second node, first two value supposed to be there. And can we check it out from our result? Yes, first one is working fine, Z11. It is over there, and all other value Z12, Z13, 14 up to 1, 33. This all are remains 0. If you see this one, yes, it's remain 0. Similarly, for Z21 it is there, plus Z22 it will be there. Then all other will be remains 0, because from this diagram Z22 is something like that. For Z3, 3 value will be there. For Z4 it is supposed to be the 4th value. For Z13 it will be something different. It is connected with only this 4 node thereafter. So just do check it out later on, it's working fine or not. So Ideally, till now, what we have do it out over there, we have calculate BIBC matrix and a BCBB matrix. Now, based on this BIBC and BCBB matrix, we are supposed to calculate what will be the our voltage on each node, or other way we can say what supposed to be the del B. So, we have to calculate the voltage. When we will able to calculate the voltage of each consecutive iteration, then only we can calculate it out the del B, and then only we can check it out whether this del B value is less than tolerance value or not. If it is not less than tolerance value, this iteration supposed to be reached to iteration number 2. So let's write if I write this is voltage at first iteration, initial voltage for first iteration, it says 1 for all of the node bus voltage. So we can write it like this way. Let's check once whether it is coming or not. No. It's supposed to be once. No. Okay. Yeah. This is we have considered initial voltage for all node bus is as 1. So we are supposed to calculate the initial bus voltage. Let consider this BB. For first scenario, it's supposed to be V1, and here we will set this convergence criteria, or we set this iteration. For initially we consider this iteration is as 0. Every time your iteration will get updated, and we will define our tolerance, and let write the value of tolerance is for first scenario, let's write del B value is 10, not as right now we are inside this loop. Here we have to check this old bus voltage and new bus voltage. So initially old bus voltage we defined in BO. So we convert this BO into BB and we defined it over there. Now for calculating the new bus voltage, what we have to do for calculating the new bus voltage, क्या था formula? That's we have to calculate it out, BIBC value, BCBB value plus what will be the node current, that is also involved over there. Node current was what is our apparent power with respect to B naught, but here till now we didn't consider this apparent thing. So here a few lines we may need to write it over there. So let's write initially, if we write it as 1, write it in matrix. Okay, before that write as is complex of this is supposed to be capital P, I think. Here we have write it as capital P. Can we write it like this way for calculating the branch current, all node current, conjugate of S into VB, the same line what is shown in equation number 1. Till now what we have done, we have formulated BIBC and BCBB matrix. Right now we are going inside the iterative law. So our this step was to calculate the node current, and the same node current we can calculate using this line number 46. The moment our node current is known, we can calculate branch current also. Now for calculating the branch current, we have to utilize this formula, what is shown in equation number 3. So therefore we calculate node current. Right now we calculate the branch current, and it's supposed to be is equal to BIBC into whatever the node current is there, and this BIBC calculation already has been done by us over there. So it's supposed to be BIBC into I. So it is okay, BIBC into I. So we hope we'll able to calculate branch current. For time being, this iteration is not completed. If I comment this part, and let's see whether IB is coming or not. We are just normally see up to this much whether our program is working or not. Tentatively yes, certain value is there. Okay, these all are the branch current we have calculated. We got the value for the branch garden. Now we are supposed to move for forward sweep method. Now if we go for forward sweep methods, in forward sweep method, if we recall that del B is usually calculated it out based on BIBC into BCBB matrix into that I current was multiplied with that. So for there, if I write direct load flow DLF is equal to BIBC into BCBB matrix, and for VB it's supposed to be right now whatever the older value of B0 minus this DLF into I, it's supposed to be. So at line number 50, can we say we get the updated voltage for this iteration at line number 50? Updated voltage. This voltage is calculated it out based on this all of this formula. Actually, this portion we have been utilized. Okay. So this is your voltage we have calculated out over there. Now this is your updated voltage. So we can say this is new bus voltage over there. So new bus voltage, it's supposed to be the B. Now if you remember, we supposed to calculate the difference of consecutive two iteration for all node. So let's try to calculate what supposed to be the value for del B. Del B value, it's supposed to be the absolute value Can we write it like this way? There is some problem in matrix dimension. Yeah. Okay. Here basically issues, I think this is our tolerance criteria. Initially we set it as 0.001, okay, and from there we defined what is our old bus voltage, which was 1, and thereafter we updated this bus voltage as line number 52. This is a new updated voltage, and while updating this voltage we use BIBC and BCBB matrix as a direct load flow, and we update this voltage and we check it out what is its tolerance value, and what is the maximum tolerance value, whether it is reaching beyond this limit or not. If it is reaching up to this limit, we stop this iteration and we calculate it out, the voltage for all node will display over there. We'll see how many iteration is going over there. We'll just see this thing. It's a very simple one, nothing is over there. Within 3 iteration, we able to achieve this bus voltage data for bus voltage data for the 34 bus system. And if we see what is minimum voltage somewhere in this note, I think minimum voltage we have obtained. Minimum voltage we have obtained, I think bus number 27 we have obtained the minimum voltage. This was that time we have shown this result 0.9417 we have obtained minimum voltage, and that was corresponding voltage of bus number 27, and the same we have been calculated right now. The same we have been calculated over there right now. That's all. And if we supposed to calculate what's supposed to be the power loss over there, definitely we can calculate it out, the power loss. Therefore the simple formula for power loss, so we have to execute. It's for power loss calculation, normal power loss into whatever the voltage at true node into whatever the current across this, based on that we can calculate it out whatever the power loss, and later on we have made this conversion into per unit to real and if we see this power loss is coming to 21.7 kilowatt, and the same is also mentioned in this table. So partially we can say it's alright, our programming is okay. Initially I had some problem, possibly some multiplication or something went wrong for forming this matrix. Okay, we have to check it out, this part mainly line number 43 to 55, it is the main iterative portion is over there. Okay, and when we able to achieve the power loss, our first lecture related to this is we have achieved. Now next part we are supposed to discuss where we supposed to place these capacitors and maybe some battery energy storage device. Therefore we may go for a certain formulation, so we have to go for optimizer algorithm. In optimizer algorithm, if we go for optimizer algorithm, at that time in this data file there will be some modification. Here your data file, your whatever the BD or whatever the active power demand over there, it will keep on changing, where you are inserting battery energy storage component or reactive power component. Based on that your PD and QD will change and a separate load flow will done, and based on that load flow we have to check whether our actual voltage is 221 or not. Just for understanding purpose, if I write here at bus number in any node, actually I will insert a certain voltage and we will see what is coming over there. Suppose I have made this modification bus number 3,27. At 27 number of bus, I am inserting a certain value of 50. So what will happen? Your bus data will be changed. So let's see what value we are obtaining over there due to this insertion. No, its program is not working. First, let's see what is this value. Actually, what I am trying to say that whatever our data file is over there, we have to do the necessary modification in data file. In this data file, if we insert it, suppose at bus number 2350 k bar, so this data file at that time will become, instead of 142.5, it will become 92.5. And due to this 92.5, your result for power loss and voltage will be something different. The same will be decided through the optimization technique. Here I can do it manually, but that is a trial and error thing. But if I use optimization, then it will give you exact result. And why should I insert it at bus number 25 or 20, where we supposed to insert that thing? Okay, so that's okay. Okay, thank you. ये कोडिंग बनाइए ना डाटा फाइल